Hello everyone, I am the trainer from Huawei Global Training Center. This chapter mainly talks about big data industry and technological trends. After this chapter, we'll be able to know what is big data, what's the trend and applications of big data technology, and I'll briefly introduce the Huawei Big Data solution. Okay, so question 1. What is big data? Well, lately, big data is gaining popularity. A lot of countries take big data as a country strategy. For example, Group of 8 has released the G8 Open Data Charter and proposed to accelerate the implementation of data openness and usability. All major economies around the world have made data openness as a national strategy to promote future economic development. China also has begun to deploy the big data industry. At the second focusing study session of the Communist Party of China Central Committee Political Bureau on December 8, 2017, President Xi Jinping emphasized that we should target cutting-edge technology and mobilize prime resources to make breakthroughs in developing core big data technology, as well as accelerate the implementation of a national big data strategy and the construction of a digital China. So what exactly is big data and why it matters? Here is the definition from Wikipedia. Big data is data sets that are so voluminous and complex that traditional data processing application software is inadequate to deal with them. While currently, big data does not have a common definition yet. Almost all definitions are given based on the features of big data. It has 4 V's: volume, variety, velocity, and value. The first 2, volume and variety, I believe is easy to understand. Why do we call it big data? Because the data volume is big, it's huge. Data comes from everywhere. For example, every second, 2.9 million emails are sent around the globe. Every day, 28,800 hours of videos are uploaded to YouTube. Every day, 15 million messages are posted on Twitter. We can see that the data volume is massive, and of this data, there are multiple types like structured data, semi-structured data, and unstructured data. The velocity means that in some scenarios like e-commerce or a social network, data needs to be analyzed fast and effectively. The value means that with more and more data, when we dig information from massive data, the value density of data is low. No matter what you are doing right now, actually you are doing data business. Data about your customers is as valuable as your customers. In the past data era, we use files, folders, and desktops. When entering into the Internet era, data is displayed on web pages and links. And today, we take data as a cloud, or a tag, or a stream. Now everything is in our data streams. However, what's important is not the data, not the big data, but how to analyze and find the values of data, and then to take measures to enhance the operational capacity in every industry. So what's the difference between traditional data and big data, or we can say small data and big data? Let's take a look. So first one is about data scale. Well, the scale of traditional data is usually MB or GB level, and big data usually refers to TB or PB level. And with the development, I believe in the future, PB level may be regarded as small data because small and big are relative. And for data type, Small data form is single, mainly structured data. But for big data, it includes structured data, semi-structured data, and unstructured data, all of them. And for traditional data, first schema, then data. And for big data, first data, then schema. How to understand that? Let me take the example of LMS, which is Library Management System. Well, it's a resource planning system for a library. So when I'm trying to build an LMS, I need to design the system first, then I put data into it, such as information of people, books, and the borrowing relationship and so on. This is what I mentioned about first schema, then data. But for big data, no matter what kind of data, I collect all of them, and then I start to think about what I want to do with them, what I want to get from all this data. So the thinking logic of these two are totally different. As for the processing tool, well, it's always the same in the past. Basically, we just use IOE, which is IBM, Oracle, and EMC. All the systems of the IT companies or carrier industry are built using IOE. With IBM Server, Oracle the database, and EMC data storage, we can build a system such as human resource system or office automation system. However, right now it's more about mix. For example, if your company wants to build a system for massive data storage, we can build a Hive cluster or HBase or HDFS, or let me give you another example. Like for transportation industry, we have real-time traffic data, so we need a system with stream data processing or real-time processing. We can use Storm or Spark. Okay, that's some differences between small data and big data. Here are some examples showing the data volume generated each day by Chinese internet users is huge, like the Taobao website, Baidu company. And with the following events happened like decrease of hardware costs, acceleration of network bandwidth, emergence of cloud computing, popularization of intelligent terminals, e-commerce and social networks, comprehensive applications such as electronic maps, and IoT, we are entering the era of big data. However, big data is not omnipotent. It cannot solve everything. No matter when, it's people who are speaking and thinking. Big data is just a new tool for helping people processing problems. So what cannot be done by big data? Okay, first, it cannot replace management decision. Who to decide? It's the leader of a group or a company. Data is just used for reference only. Second, it can't replace effective business model, or we can say business mode. Let me give you an example. In China, we have a lot of social softwares like WeChat, Weibo, QQ. They are similar to Facebook or Twitter. So actually, the competition of social softwares in China are intense. Those softwares I've mentioned, like WeChat, Weibo, is for individual users. And there is another social software called Xingge. It knows that it cannot compete with these softwares, so it changed its business mode. It's designed for enterprise users. It's only open to internal employees who can register by real name and mobile phone. So this story tells us that big data cannot decide the business mode. We do. And third one is that we cannot find knowledge without purpose by big data. Like AlphaGo, a chess robot. I have to give it a go or some constraints. Fourth, big data cannot replace the role of experts. Every time you build a model, you need an expert to decide whether the model is good or bad. Here, experts usually refer to business staff or data analysts. And the last one is that once we build a model, it's impossible to use the model all the time. For example, like Carrier, the marketing mode is changing all the time because the need of customers is changing all the time. So, the models need to be constantly updated. Then, let's take a look at the big data applications. The core of big data era is to see through the essence of business clearly, to predict the development trend and to guide the future. So the key of big data here is to predict, to mine the values of data. Big data exists, I can say, every industry. Here shows some examples: retail, finance, city, medical treatment, sports, education, telecom, and many other industries. So for politics, here shows an example of United States presidential election in 2016. Trump finally becomes the president by the way of big data analysis. Based on user behaviors on Facebook, it can analyze the personalities and political directions of each user and divide them into three groups. And then Trump started to post messages directly to Americans by Twitter, and every tweet is actually a little bit different for each user, trying to win over voters psychologically. In finance, traditionally we need to go to a certain place in a set period of time to obtain services like banks. But right now, we can obtain services anytime and anywhere through online banking. Besides, through data analysis, the new financial institutions can provide personalized services to customers. Let's take a look at a specific example of Walmart. Walmart is an American multinational retail corporation that operates a chain of hypermarkets, discount department stores, and grocery stores. We know that there is a 4-hour time difference between East Coast and West Coast. So when almost by noon in the East Coast, it's only 8 a.m. in the West Coast. So Walmart came up with a strategy. It made analysis of sales in the East Coast first, and then applied the result to the West Coast. For example, based on today's sales in East Coast, it's shown by analysis that the fruit sales is pretty high, so we can increase the supply of fruits in the West Coast in order to maximize the profits. Actually, Walmart processes detailed data about 145 million customers in the USA, which is about 60% of American adults. Walmart uses in-store Wi-Fi to collect information about goods purchased by customers, their residence, and their favorite products, and the big data team of Walmart will analyze the clicking behavior of customers on Walmart official website, in-store and online purchase of goods, trends on Twitter, and the influence of local activities and weather deviations on the purchase modes of customers and so on. All activities are captured by the big data algorithm and analyzed to identify valuable information, which can help millions of customers to enjoy personalized shopping experience. In education, big data provides technical support for elementary education and higher education institutions to analyze all important information, such as students' psychological activities, learning behaviors, exam scores, and career planning. The ultimate goal of big data analysis is to provide personalized services for improving the academic performance of students. Meanwhile, big data analysis can improve students' final exam scores, daily attendance rate, dropout rate, and rate of admission into higher schools, as well as promote balanced education development. As for transportation, well, about 200 million mobile phone users in China use Baidu Map. Each time the user location is changed, Baidu company can obtain the data. The location information of the mobile phone users can be collected as big data to make analysis for outlining the migration tracks of people. This figure displays the transportation situation during the Chinese Spring Festival. It's an innovation based on the local-based service technology. The data is updated every 8 hours, covering railway, highway, and airlines across China. It's shown by the analysis that within 500 kilometers of driving, it's better to choose railway because it's the highest cost-effective. As for tourism, we can provide suitable touring packages based on different ages, hobbies, and economic capabilities, and we can also avoid potential tourism risks. To be more specific, we can predict the ticket price for different places based on big data. For government and public security, we can, for example, use cloud computing and a large amount of data to locate the areas that are most vulnerable to criminals, create a hotspot map for crime-prone areas. When studying the crime rate of one region, various elements of adjacent regions can be considered to provide support for policemen to log crime-prone areas and capture escaped criminals. About traffic planning, well, we can analyze the traffic crowd based on different ages or different ways of getting to some places, or we can pay more attention to those regions of which the human traffic is over the threshold in history. And based on these results, we could make road network planning or bus line planning in order to optimize the transportation modes. As for sports, for example, we could make analysis of famous football stars like Cristiano Ronaldo or Lionel Messi, to analyze some information such as his way of scoring goals, number of goals scored in different league competitions, and shooting area. Thereby we could obtain the scouting reports so the coach can make a targeted deployment before the competition. Next, let's take a look at some opportunities and challenges in the big data era. With the increasing volume of data, if we continue to use the traditional framework, which is mini-computer, plus RAID, plus commercial data warehouse, it would cost a lot. And the performance of batch processing is insufficient. And it also has some other weakness like single data source and so on. So the traditional data processing technology is not enough for us to process big data anymore. And about the industry applications of big data, we have a lot, like for operation, it could be used for operation analysis, or a financial bill, or electricity distribution. For management, it could be used for social security analysis or tax analysis. And for supervision, it's usually for the government. So actually, this page is trying to show you that every industry is developing big data. However, it's unavoidable to meet some challenges. Here mentions 7. Let's take a look. First one, departments do not have clear requirements on big data. It's true that most business departments do not know a lot about big data, so it's hard for them to come up with accurate demand. Second challenge, In most large enterprises, different departments cannot share data with each other, so the value of big data cannot be fully used. But the advantage of big data in understanding customers and services can be fully represented by correlating and integrating different data. Third, most enterprises pay no more attention to data processing, which results in low data availability and poor quality. Actually, data processing is a very important step, which may affect the following data analysis phase. Fourth, traditional database is not enough for processing big data, so we need new data management technology and architecture that can handle TB-level data or above, can process multiple types of data, can process data in real time, and so on. Fifth, it has a great concern about individual privacy problems. At the times of informationalization and transparentness, some shopping apps can get your shopping habits. All kinds of website registration can get your personal information. Your habit, your information are totally transparent to these service providers. What if information leakage happens? It may result in identity theft. An organization or an institution or a company will inevitably suffer great or small loss. Besides, there is a lack of big data talents. Each step of big data construction must be completed by professionals, so we need talent who knows about big data and has big data application experience to construct big data platform. And the last one is about balance between data openness and privacy. We need to ensure data openness and sharing, but in the meantime, we need to protect the privacy of citizens and enterprises. How to do that is a big problem for us. Big data is developing from batch processing to real-time processing. Hadoop provides the foundation for big data batch processing, but it cannot provide real-time analysis. Here is an example of Hadoop practice in the industry. The Intel company develops a new architecture of Hadoop, which is 3 times faster than the Hadoop. And the MapReduce is featured with the snapshot function and compatible APIs and has no single point of failures. Besides, this architecture uses SSD and CPU instruction optimization technology, so the query speed is 10 times faster than that of open-source HBase. Out of the Hadoop, Intel maintains an open-source project named Panther, covering the instant analysis, document storage, and SQL analysis engine. And here is an example of in-memory computing practice in the industry, the Google Power Drill. It has the performance of querying trillions of cell data per second, which is 10 to 100 times of the traditional column-oriented storage performance. Power Drill can quickly skip unnecessary data blocks. Compared with the full scanning performance, the Power Drill performance is improved by 100 times, and it uses the compression and encoding technologies to optimize the memory usage space. As for stream computing, the IBM's InfoSphere Streams is a very good example. It's one of the core components of IBM's big data strategy, supports high-speed processing of structured and unstructured data, throughput of millions of events per second, high expansibility, and the streams processing language. In today's big data era, the commercial ecosystem has undergone tremendous changes unconsciously. The boundary between Internet users and consumers is becoming ambiguous. Intelligent devices everywhere, online network transmission at any time, and frequent interactions of social networks make the previous web users come into the limelight. For enterprises, they have a chance to conduct large-scale precise researches on consumer behavior for the first time. Actively embracing this change and undergoing the self-dramatic change and evolution from strategies to tactics will let enterprises better adapt to this new era. The big data blue ocean strategy becomes the high ground of future competitions. And these are just some types of big data talents, like big data system R&D engineers, big data application development engineers, and big data analysis, and so on. Then let's take a look at Huawei Big Data solution called Fusion Insight. This is the architecture of Huawei Fusion Insight, which are the following four parts: Hadoop, Data Farm, Manager, and Libra. The Hadoop layer is developed based on the open source version, and it provides data processing environment. The data farm layer is used for data insight, which includes Porter for data integration services, Miner for data mining services, and Farmer for data service frameworks. And Manager is a distributed management framework that includes system management, data security management, and data governance. And Libra is an enterprise-level relational database with large-scale parallel processing capability. It supports both row storage and column storage. Here shows the core capabilities of Huawei Big Data Team. Huawei Big Data Team is not only capable of using Hadoop, but also able to lead the communities to develop future-oriented kernel features and establish top-level projects that are adaptable to the ecosystem in the communities. In China, there are a lot of enterprises that are cooperating with Huawei, such as Industrial and Commercial Bank of China, China Merchants Bank, or China Mobile, China Unicom. So this chapter just simply introduces background of big data, some applications, opportunities, and challenges brought by big data, as well as Huawei Big Data solution. Okay, that's all for big data industry and technological trends. Thank you.